Okay, in the following problems, determine whether the hypothesis of Rolle's theorem hold for the function f on the given interval, and if they do, verify the conclusion of the theorem. So remember, the hypothesis is to mean that now the function is differentiable and continuous, differentiable on the open interval and continuous on the closed interval AB. So the first, we have f of x given by x squared minus 2x minus 3 on this closed interval -1 to 3. So our solution for this one, clearly f of x is differentiable and f of -1 equals to f of 3, which is 0. So hence, so when you say differentiable, then it's actually also means continuous. Remember, differentiability means continuity. Hence, Rolle's theorem applies. So therefore now let's get the f prime of x will be given by 2x minus 2. And then to get that c, so we solve this equation. So f prime at c should be equals to 0. So which means 2c minus 2 equals to 0. So 2c equals to 2, c equals to 1. So we obtain excuse me, x equals to 1 is a critical point. Thus, f prime at 1 equals to 0. And since -1 is between -1 and 3, then it is true that the function satisfies the Rolle's theorem. Example 2, so f of x is given by x cubed minus x on 0 to 1. So solution, f of x is differentiable with f prime of x given by 3x squared minus 1. Also, f of 0 is the same as f of 1, the same as 0. So thus, the Rolle's theorem applies. So setting f prime of x to 0, i.e. 3x squared minus 1 equals to 0, means that x equals to plus or minus square root of 1 over 3. So there are two values of x, so which means that x equals to minus root 1 over 3 or x equals to positive 1 over root 3. So from these two values, the positive solution x equals to square root of 1 over 3 lies between 0 and 1. Thus, it is the value of c that satisfies the Rolle's theorem for this given problem. Number 3, f of x given by x power 4 minus x squared on minus 2 to 2. So for this problem, solution, the hypothesis of Rolle's theorem are satisfied because f is differentiable and therefore continuous everywhere, and f of 2 is the same as f of minus 2. So which is given by 12. You can easily see from here that f of 2 equals to 2 power 4 minus 2 power 2, which is 12. And also f of minus 2 equals to minus 2 power 4 minus minus 2 square, which is still 12. So we must verify that f prime of c equals to 0 has a solution in this open interval. So this is the conclusion of the Rolle's theorem. So since f prime of x equals to 4x power 3 minus 2x, which is 2x into 2x squared minus 1, we need to solve 2x equals to 2x squared minus 1 equals to 0. So the solutions are c equals to 0 and c equals to plus or minus 1 over square root of 2, which is roughly plus or minus 0.707. So since all lie in this open interval from minus 2 to 2, so Rolle's theorem is satisfied for all values of c, for all the 3 values of c. Last example, we have f of x given by x squared minus x minus 6 over x minus 1 on the interval minus 2 to 3. So for this function, so discover that there is a discontinuity at x equals to 1, since limit as x approaches 1 of f of x does not exist. So hence, Rolle's theorem does not apply. So therefore, just stop at that point, because we can't go further once the first hypothesis that f is differentiable. So if there's a discontinuity, then it's not continuous, so not differentiable at x equals to 1. So Rolle's theorem cannot apply for that given function. And then the last example, if x is not equals to 1 and x is in -2 to 3, and then -6 if x equals to 1. So this is a piecewise defined function. So solution, notice that x cubed minus 2x squared minus 5x plus 6 is the same as x minus 1, x squared minus x minus 6. Hence, f of x equals to x squared minus x minus 6 if x is not equals to 1 and x is in -2 to 3 when you cancel out. So therefore, but f of x equals to -6 equals to x squared minus x minus 6. When x equals to 1. So f of x equals to x squared minus x minus 6 throughout the interval from -2 to 3. Also, note that f of -2 is the same as f of 3, which is the same as 0. So hence, the Rolle's theorem applies. So now f prime of x will be given by 2x minus 1. Now setting f prime of x to 0 implies that x will be a half. So since a half is between -2 and 3, then the Rolle's theorem applies for f. So do as many examples as possible on the same application of Rolle's theorem. Thank you.